Section 1.3, Solving Quadratic Equations. An equation is quadratic if it can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not 0. Example number 1, we're determining whether or not these are quadratic equations. At first glance, a may not look quadratic, but if we distribute and set it equal to 0, we can see that it is quadratic. X squared minus 4x is equal to 3x plus 2. And then x squared minus 7x minus 2 is equal to 0. It is quadratic. B is not quadratic. Right away, we can see that there's division. We're dividing by x. That makes this a rational equation, not quadratic. There's 4 different ways to solve a quadratic equation. One is set it equal to 0 and factor. Method 2 is the square root method, then completing the square and the quadratic formula. In this example, we're going to factor. When we're factoring, we need to first set the quadratic equal to 0. So we'll subtract 5x on both sides. And from here, we can set up our 2 parentheses. X will be the first part in each set. And now we have to ask ourselves what 2 numbers multiply to 6 and add to -5. -3 and -2. They multiply to C, in this case 6, and they add to B, in this case -5. From here, we use the zero product property to set each factor equal to 0. And from here, we have 2 simple equations to solve. X equals 3 and x equals 2. Next, we're going to factor again. So first we need to set it equal to 0. 5x squared minus 12x plus 4 equals 0. Now this time we're going to use what's called the AC method. AC is coming from the generic ax squared plus bx plus c equals 0. So a and c in this case is 5 times 4, which is 20. And now we have to ask ourselves what 2 numbers multiply to 20 and add to -12. 2 numbers that multiply to 20 and add to -12 are -10 and -2. So what we're going to do is we're going to rewrite this middle term using -10 and -2. 5x squared minus 10x minus 2x plus 4 equals 0. Notice that -12x is the same thing as -10x minus 2x. Now we have 4 terms. From here, we're going to use grouping. Look at the first 2 terms and focus on just those 2 terms. Factor out their greatest common factor. In this case, we get 5x, and we're left with x minus 2. Now focus on the last 2. Look at just those last 2 terms and factor out their greatest common factor. In this case, -2. We're left with x minus 2, and that's still equal to 0. Notice that the parentheses are identical. At this point, they should be. So we're going to factor again. What does this term and this term have in common? The x minus 2. And when we factor out the x minus 2, we're left with 5x minus 2. So the second set of parentheses is 5x minus 2. And that's equal to 0. From here, we're going to set each factor equal to 0, just like we did earlier, and solve. X is equal to 2 and x is equal to 2/5. Now the AC method is just one way to solve quadratics where the a, the leading coefficient, is other than 1. There are other techniques. If you learned a different technique in the past, it still works. AC is just one method, one way to do it. Here, again, we're going to factor, so we need to set everything equal to 0. So we'll subtract the 10 over, setting it equal to 0. Notice again, a is not 1, so we need to use the AC method. A times c in this case is -30. So what two numbers multiply to -30 and add to -1? That's -6 and 5. So we'll rewrite our quadratic, mainly rewriting that middle term as -6x plus 5x minus 10 equals 0. Pull out the GCF from the first two terms. Their greatest common factor is 3x. You're left with x minus 2. Now look at the last two terms and factor out their greatest common factor. In this case, 5. We're left with x minus 2. Notice the parentheses are identical. That means we're on the right track. We'll factor out x minus 2, and we're left with 3x plus 5. Still equal to 0. Now set each factor equal to 0. And solve. X is equal to 2, and x is equal to -5/3. In the next example, we have a little bit of extra work to get it to standard form. We need to distribute first. And now we'll set it equal to 0 by adding that 11x over. So we get 6x squared plus 11x plus 3 equals 0. Again, here we'll use the AC method since a is not 1. A times c is 18. Two numbers that multiply to 18 and add to 11 are 9 and 2. So rewriting that equation, 6x squared plus 9x plus 2x plus 3 equals 0. Look at the first two terms. Their greatest common factor is 3x. We're left with 2x plus 3. The last two terms have nothing in common other than 1. We'll just factor out the 1, and we're left with 2x plus 3 equals 0. Parentheses are the same. We'll factor out those parentheses, and we're left with 3x plus 1 equals 0. Again, we'll set each factor equal to 0 and solve these equations. Here, x is equal to -3/2, and x is equal to -1/3.